This question is an electrolysis question. Let's just get right into it. Part A of number 4. Jack was required to conduct an investigation on the electrolysis of concentrated sodium chloride solution. Very important word there, concentrated sodium chloride solution. It makes a big difference. Identify 2 ions present in the electrolyte and include their state symbols. If we're talking about concentrated sodium chloride solution, then naturally we're going to have sodium ions, Na plus ions, aqueous, it's in aqueous medium. Would also have chloride ions, that's Cl minus. And they ask for 2. We could also give, we'll just put this on the side, we could also give H plus ions, aqueous, and we'd have OH minus ions as well. But they ask for 2. Next question. State 2 factors that affect the discharge of an ion in the electrolyte during electrolysis. So we have 3 factors. We have the position of ions in the electrochemical series. We have relative concentration, and this is for halides, electrolytes containing halide ions. And we're only going to give 2. We can state the other one, the nature of the electrode used. Part 3, predict which ions present in electrolyte will be attracted towards the anode. So what I normally do here, or recommend that we do, we just remind ourselves what the anode is. The anode is the positive electrode. So opposite attracts, so we'll expect the negative ions, aka the anions, to be attracted to the anode. So the anions, that would actually, the anions here are OH minus ions, aqueous, and Cl minus ions, aqueous. So those are the ions that would actually be attracted towards the anode. They will migrate. And of course, the one that gets discharged or liberated now depends on the factors that were just mentioned in part 2. So normally, OH minus would be liberated because it's at the bottom of the electrochemical series and it requires less energy to be liberated, right? But in this case, we have concentrated sodium chloride solution, and we said that the concentration makes a difference. So this time around, the relative concentration would actually trump the position of the ion in the series. So chloride, though chloride is higher in the electrochemical series of anions than OH minus, would find that the chloride ions would actually get the go ahead. So just a reminder, the electrochemical series for anions: carbonate, sulfate, nitrate, chloride, bromide, iodide, and OH minus. So under normal circumstances, if we were looking at a dilute sodium chloride solution, then the OH minus would be liberated preferentially. But in this case, we have a concentrated solution of sodium chloride. So concentration trumps relative position in the electrochemical series. So as we said earlier, the chloride would actually get the nod. And if the chloride gets the nod, we're at the anode. So oxidation occurs at the anode. So we would have loss of electrons taking place. So we would have our chloride ions, Cl minus, aqueous, and we put our arrow, and that would give us chlorine, elemental chlorine, plus the electron that's given up. But of course, chlorine is diatomic, so we'd have to write this as Cl2. So this reaction would take place twice, and the moment it happens, we'd end up with chlorine being formed, Cl2. So this is our balanced chemical equation for what's happening at the anode. 2Cl minus aqueous to give chlorine gas, that's Cl2, plus 2 moles of electrons. And That would have given us all of 2, 4, 6, 8 marks. This question is for 15 marks, so we're a little over halfway there. Part 5. Write a balanced chemical equation for the reaction at the cathode. So we would have two ions, two types of ions migrating to the cathode. We would have Na plus ions, aqueous, and we would have H plus ions, aqueous, actually migrating to the cathode, but only one of them would actually be liberated. So in this case, our hydrogen would be liberated preferentially over our sodium. So even though there is a higher concentration of the sodium, the Na plus ions over the H plus ions, we would not have the concentration of the, we would not have concentration playing a role here in which cation is liberated. So even though more Na plus ions would be there relative to H plus ions, the H plus ions would still be liberated. It would require too much energy for the Na plus ions to actually be liberated. So this is the opposite of bonding. Breaking up in this case is really hard to do. So the H plus ions would actually get the nod. Just a reminder, our electrochemical series. So hydrogen would actually get the nod. So we're just going to look at what happens in this case. So reduction is occurring at the cathode. So we'd have the H plus ions being discharged. So we'd have gain of electrons this time. And please note that we have the species plus the electrons, and then we have whatever the final product is. But of course, we know that we cannot write hydrogen as just H. Anything that ends in or gen is diatomic. So the moment this reaction occurs, and it occurs a second time, we'd have the elemental, we'd have the atoms of hydrogen combining to give us H2. So we just need to put a 2 in front of the H plus and in front of the electrons, and we're balanced. So that's that. Part B, state whether each of the substance given in table 2 are classified as conductors or non-conductors. Magnesium ribbon, metals are good conductors of electricity. We're assuming that they're talking about electricity, seeing that we're on an electrolysis question. So magnesium ribbon would be a conductor. Plastic ruler is a non-conductor. An aqueous solution of magnesium chloride. Aqueous solution of magnesium chloride. Magnesium chloride is an ionic compound. So in aqueous medium, the ions would be set free and can carry a current should a voltage be applied. So this would be a conductor. Conductors allow electricity to pass through them. I saw something the other day, properties of a conductor. It does not give back phase change. Not the kind of conductors we're talking about here. We're talking about things that allow the passage of electricity through them. Part C, carbon is an example of a non-metal. State 2 uses of carbon. Now, the uses here are many. We're going to look at the direct uses of carbon. Carbon can exist in 2 forms. We call those allotropes. We can have carbon in the form of diamond. We can have carbon in the form of graphite. So for as diamond, carbon is used as jewelry. Right. It's also used as drill bits. We just need one. The only thing that can be used to cut diamond is another diamond. And as graphite, carbon is used to make electrodes in industries. It's also used to make the quote-unquote lead in pencil points. And just like that, we would have gotten the remaining 7 marks. So this is out of 15. So thank you again for joining Chem with Chem. Please check out the other materials that are on the channel. Be sure to share, leave a like if you find value, and consider subscribing and turning on post notifications so you'll be kept up to date each time content is added. Copper later.